All right, starting my video. So for this one, we are going to do option 2 because instead of having y equals a bunch of stuff, we have x equals a bunch of stuff. So it's by far easiest to just let y equal t and plug that in here to get our x equation. So x would just be equal to t to the 5th plus 2t plus 1. Do you see what I mean? By choosing t to be either x or y, depending on which one is going to be the easiest. Keep it simple. All right, so next we get, well, that's actually it right there. Those are our equations. I guess I could have just taken this and moved it right there, and there's our system of our group of parametric equations. So now just to figure out what the restriction would be, they didn't tell us any restriction. So I don't think there is one. And this is an odd power. So I think it's going to be one of those like sideways John Travolta graphs from our math disco. And it's just going to go from negative infinity to positive infinity. Something like that. I didn't even care about where the points are. That's just an approximate graph, just for reference purposes. Because it didn't ask us to graph it. I just am a very visual person, so I like to have the graph to solidify in my head what's happening. If you don't need it and don't care about all that extra work I'm going to, then that is fine. All right, this one's a little bit trickier. We're doing a directed line segment with an initial point here and a terminal point there. Basically what that means is we're creating the equation of a line. And remember, the equation for a line is like y equals mx plus b. Okay, so in here, item 3, I didn't mean to cross it out, sorry. Item 3, for a directed line segment with initial point and terminal point, let x equal x naught plus x1 minus x naught times t, and y equal y naught plus y minus y naught t for 0 to 1. Okay, so let's go ahead and just follow that formula. But the idea behind it is we're finding these linear equations. So for x, we're going to take our initial point. So let me go ahead and label these. x0 initial, x1, so x naught is usually how that's said when it's a 0. And then this one would be y naught. Why not? I don't know. Sorry. Dumb. Anyway, moving on. So x would equal x naught, which is 2. And then I'm just following this formula right here. x1 minus x naught, which would be 1 minus 2. And that would be times t. So that's kind of like giving us our slope because it's the rise over run for just those x values, right? And then the variable is t. So that's why we're not doing like, we're not actually doing a run. We're just doing like the x distance from here to here is going to be the slope for this line with parameter t. Okay, let's simplify this a little bit. So 2 plus negative 1t, or I think this would look better if we did negative, no, I guess that looks, they've left it that way. If you like it in the form y equals mx plus b better, you could put the negative t first, or you could just rewrite it as 2 minus t, and that would be fine as well. All right, so now let's go ahead and do y. So y would be this part here. So y naught is negative 3. And we're going to go 5 minus negative 3. Don't forget your double negatives there. So that gives us negative 3 plus 8t. So there's our y parametric equation. And it already says that this is just automatically going to be t from 0 to 1, which is interesting. So here's our final answer. Negative t plus 2. Oh, I forgot the x equals. X equals negative t plus 2. And then just because I like the y equals mx plus b format a little better, it doesn't matter. Really doesn't matter at all. 8t minus 3. And this is going to be for 0 is less than or equal to t is less than or equal to 1. So to graph this, if you needed to graph it, which it doesn't say to, but since we've been doing that, I don't think it hurts. You've got the graph paper right there for you. So I'm just going to start at the point 2, 3 to negative 3, and then the point 1, 5. So it starts here, ends there. And why bother doing it the way we did them in 8.1 when we've got that information right there? We don't need to go backwards and recreate it. It's already there for us if we needed to graph it for some reason. Just preparing us for that if needed. So starts here, ends there, directed line segment. Here's our set of parametric equations. It didn't even ask us for an equation that fulfills this. We don't need the equation that's just x and y, though at this point we could probably write it from here. You know, we just need the slope and y-intercept for this line, but it didn't ask us, so we're not going to bother doing that.